Let me read the question now. Diagram 9 shows a triangle. As you can see here, this is not an ordinary triangle, it is a right angle triangle. Okay, as you can see here, the height is 2 to the power of x plus 1, the base here is square root 2 to the power of x, and the hypotenuse is 3 times with square root 2. Okay, so the question asks us to find the value of x. So this is for the question part A. For the question part B, diagram 10 shows a trapezium. Okay, so this is the trapezium. Okay, given that area of trapezium is 9 times with the surd 7 minus 1, you can call it square root 7 or surd 7, okay, it's up to you. Okay, centimeter square, express t in the form p plus with q surd 7 such that p and q are constants. So this is the overall question. Okay, so without further ado, let us start our discussion for the question 14 part A. So as you can see here, this is a right angle triangle, and whenever you see a right angle triangle, we always imagine ourselves with the Pythagoras theorem. Okay, Pythagoras theorem, you can relate it with c square is equals to a square plus b square, and you can also describe it as c is equals to square root of a square plus b square. Both are just the same, guys. Okay, c is representing the hypotenuse and a and b representing the length of the two sides of the right angle triangle respectively. Okay, so now what we're going to do is we're going to relate those formula based on the given information in the diagram 9, and we're going to apply it, and that's how you're going to find the value of x. And this question will be the application of indices. Okay, we're going to apply the index principles, and that's how you're going to find the value of x. Okay, enough with the explanation, let us dive into the question. Okay, so from here let us start. Okay, similar concept of the Pythagoras theorem, so we're going to apply it. So 2 to the power of x plus 1 square plus with square root 2x square, okay, in a bracket square root 2 to the power of x square is equals to square root 3 times with square root 2, okay, and then you put the whole thing square. Okay, this is representing the a square plus with b square is equals to c square. Okay, this c is representing the hypotenuse, the longest length in the right angle triangle. Okay, so back to our working here. So from here the square you times in, so from here you get is 2 to the power of 2x plus 2, okay, and then plus with the square root and the square will get cancelled off, so you're left with 2 to the power of x, okay, and then equals to, okay, the square you times in, or you can expand this as 3 square root 2 times with 3 square root 2. From here you get 9 times with 2, okay, and 9 times with 2 you will get is 18. Okay, so from here let us continue. So this 2 to the power of 2x plus 2 we can break down into two separate components through multiplication. Okay guys, okay, multiplication, okay, when you multiply two of the same base and then later on you'll add the index. Okay, that's how we're going to break down it. Okay, so please stay with me. So from here 2 to the power of 2x, okay, in a bracket times with 2 square plus with 2 to the power of x is equals to 18. Okay, now you have noticed something. This 18, no matter how much we simplify, we still can't get up to the base 2. We can't form literally the base 2 unless over here if we have number 8, then we might have a chance. Okay, 2 to the power of 3, and then we can literally compare them, and that's how we're going to get the base. But here the case is different, the scenario is different. So how are we going to solve this type of indices question? Okay, so what we're going to do is we're going to treat this 2 to the power of 2x as a quadratic equation. This we're going to treat it as a quadratic equation. Wait, how are we going to treat it as a quadratic equation? So please hold on guys, I'm going to explain you step by step. Okay. So now what we're going to do is this 18 from the right hand side, we're going to move it to the left hand side. Okay, so 2 to the power of 2x times with, okay, so this 2 square we can expand it become 4, okay, plus with 2 to the power of x minus 18 equals to 0. Okay, so now we can literally treat as the 2 to the power of x as letter x itself. Okay, which means 2 to the power of x is x, where 2 to the power of 2x will be x squared. Okay, you can understand what I mean or not? That concept you're going to apply over here. So from here, we're going to factor out this in a respect of the base 2 to the power of x. We're going to treat it as a quadratic equation. Okay, to prevent confusion, what I do, this 4 I place it at the front over here. Okay, I think now it's better that you can able to visualize. Okay, so from here we're going to factor out this expression. So from here 4, you should get 4 in a bracket 2 to the power of x close bracket plus with 9 okay, close square bracket, and then times with 2 to the power of x minus 2. Okay, remember guys, try to recall back. Okay, when you times this 2 together, you will get back 4 times with 2 to the power of 2x. Okay, and then when you times this and then plus with the product of this, you will get back 2 to the power of x. 4 times with 2 to the power of x times with negative 2, you get is negative 8 2 to the power of x, and then plus with 9 times with 2 to the power of x, you get is positive 2 to the power of x. Okay, I know it's a bit complicated, but please follow with me guys. Okay, this question is considered to be new. And then 9 times with negative 2, you get is negative 18, and that's how you split into two factorization. Literally we're treating this as a quadratic equation, like quadratic equation. Okay. So from here we're going to have two possible answers. From here we might have only one, or we could possibly have two answers. So let's check it out. Okay, so from here 4 in a bracket 2 to the power of x will be equals to negative 9. So from here 2 to the power of x is equals to negative 9 over 4. Okay, this is your first step. Okay, let us move on to the next step. 2 to the power of x is equals to 2. Okay, we have two scenarios here. Let us check the first one. Okay, 2 to the power of x can never be equals to negative 9 over 4. Okay, why am I saying so? Because regardless of any numbers guys, whether it is positive number or negative number, you can never get a negative answer over here, because that is the function of a base 2. Okay, base 2, you can have 2 to the power of negative 1, 2 to the power of negative 10, 2 to the power of 100, any real number, you will still end up getting a positive number. So this is not possible. Okay, let us check at the second working. 2 to the power of x equals to 2. Okay, we can compare this. 2 to the power of x is equals to 2 to the power of 1. Okay, and therefore you get your answer, x is equals to 1. So let me underline the solution. Okay, why we cannot get negative 9 over 4? Because any x value will result in positive value. Okay, any x will show you get a positive, but it is impossible for you to get a negative value. Okay, you will not get a negative value in this case. So we're done with question part A. Let us move on to the question part B. Okay, so for the question part B, so it is mentioned that the area of trapezium is 9 times it's 7 minus 1. Okay, and then they give you all the respective information over here. Okay, they already give you the A and B, the length of the two sides, and then plus with the height over here. So now what you're going to do is we're going to apply this information given by the question, and then we're going to compare it with the area given by the question over here, which in this case is 9 times with 7 minus 1, or square root 7 minus 1. Okay, it is up to you. Okay, so we're going to compare with that. Okay, and most important, we need to express t in the form of p plus with q square root 7. Okay, in this type of form. Okay, let us start our discussion for the question part B. Okay, so from here, let us include the area of trapezium. So how we're going to do is, we're going to start by comparing with the area of trapezium with the one we are calculating right now. Okay, so from here, half times with square root 7 plus with 5. Okay, we can do that, but we need to make sure that we need to express in this particular form, which in this case will be 5 plus with square root 7. Okay, so please be careful, guys. Okay, half times with 5 plus with square root 7, okay, times with the height, in this case is t. So from here you should get equals to 9 times with square root 7 minus 1. Okay, so let us rearrange this equation. So from here, 5 plus with square root 7, okay, times with t, okay, and then you divide with 2, you should get equals to 9 times with square root 7 minus 1. Okay, so for the next step, this 2 from the denominator you times the right hand side. So from here you should get 5 plus square root 7 times with t equals to 18 times with square root 7 minus 1. Okay, so since we are finding the t, so what you're going to do, 18 surd 7 minus 1, okay, we're going to divide with 5 plus with surd 7. Okay, if you leave your answer in this way, you will not get the full marks, because it is important for us to rationalize the surd. So how are you going to rationalize the surd? So we're going to times the denominator with conjugate of the surd. So in this case, the conjugate of 5 plus surd 7 will be 5 minus surd 7. Okay, when you times the conjugate in the denominator, it is important for you to apply it at the numerator as well. Okay, 5 minus surd 7. Okay, you times the denominator, and it's important for you to times at the numerator as well. Okay, times here and times here. Okay, so from here t will be equals to, okay, let us start with the denominator, it'll be slightly easier. A minus b times with a plus b is equals to a square plus b square. That is the one you're going to apply here. So from here, 5 times 5 you get is 25. Okay, 25. Okay, and then minus with 7. Square root 7 times with square root 7 you get is 7. So 25 minus 7, so technically you get 18. Okay, so let us perform the expansion, okay, one by one. But before that, okay, let us expand the 18 inside. So from here you get is 18 square root 7 minus 18. Okay, so now we can able to perform the expansion. So 18 square root 7 times with 5. So from here you get is 90 square root 7. Okay, and then times with 126. Okay, 18. Okay, times with negative 7. So from here you get is negative 126. Okay, and then negative 18 times with 5. So from here you get is negative 90. Okay, and then times with positive 18 surd 7. Okay, negative 18 times with negative surd 7 should get this positive 18 surd 7. Okay, so from here, calculate, start with the surd first. Okay, 90 surd 7 plus with 18 surd 7, you should get is 108 surd 7. Negative 126 minus with 90, you should get 216. Divide with 18. Okay, so from here, can you simplify this? Okay, yes you can. So we can simplify the 18. Okay, so from here, when you divide the whole thing by 18, you should get okay, so let us factorize the 18 from here. So you should get 6 square root 7 minus 12. Okay, divide with 18. So the 18 and 18 will get cancelled off. Okay, 1. So from here you should get your t is equals to 6 times with square root 7 minus 12. So this is your answer for the question part B. So let me underline the solution for question part B. Okay, so let me scroll the question up. So that is all for my discussion for the question 14 SPM 2021 Add Maths paper 1. If you like this video, make sure that you give a thumbs up. If you haven't subscribed to the channel, make sure that you subscribe to the channel and hit the bell icon for more upcoming additional mathematics tutorial videos in the future. Okay, and make sure that you share this video to your friends. Thank you everyone for your support, and I'll see you in the next video.